Alright, so what I'm going to do in this video is we're going to find the minimum speed required for the person to clear the pit. That means that their path will take them to a peak right in the center, and then they should come back to land just far enough on the other side, so that they make it across. Now, the distance across the pit was 30 meters. To solve it, we'll want to combine the horizontal motion with the vertical motion. Alright, so the horizontal formula is delta x equals vx times t, but the vertical formula is delta y equals 1/2 ayt squared plus viyt. The subscripts, of course, are just notations for me to know like what type of velocity we're talking about and what dimension we're talking about. Alright, so we have to introduce the restrictions that the delta x needs to be 30, because they need to just barely get across. And then the delta y needs to be 0, because we need them to come back to the same height that they were launched from. So this system of equations can do it for us. Alright, so instead of Vx though, I'm going to write Vi cosine of the angle of the ramp. For Ay, we'll put negative 9.8. And then in place of VIY, I'll do VI sine of the ramp angle. And the great thing is you got two equations and two unknowns, so it's solvable. Alright, so 30 equals VI. This is radical 3 over 2. That's a half. Alright, since I want VI ultimately, I'm going to solve both equations for t. That'll allow me to eliminate the t variable. It's a technique I use all the time. This t here can go away. It's going to just divide into the 0. So we'll get this. Looks like you would have t equals vi over 2. 4.905, I believe. So now, since I got t alone for both, I can take my results and set them equal to each other. So 30 times 2 over vi radical 3 equals vi over 2, 4.905, yeah. Alright, you just want to get vi alone here, of course. And what do you know? VI is 18.43 meters per second. Exactly what we had found in the spreadsheet.